So here's our second example for center of mass. And in this example, there are two things that are very, very important to note here. So we have in this figure 3 uniform thin rods, each of length L equals 22 centimeters, form an inverted U. The vertical rods each have a mass of 14 grams and the horizontal rod has a mass of 42 grams. What are A, the x coordinate, and B, the y coordinate of the system's center of mass? So the very first thing here is that we have something that has symmetry, which I mean, we can kind of fold it in half and it looks the same on both sides. So if you see that if we divide this down in the center, that it has symmetry down that center there. So what that tells us is that the center of mass has to be on that center line somewhere. We don't know the y coordinate of the center of mass yet, but we do know that the x coordinate has to be 11 centimeters because the length of each of those rods is 22 centimeters. So that x position where that center of mass is, and my picture's kind of in the way right here, but you see that this is the x-axis right here. So because this top rod right here is 22 centimeters long, that x position of the center of mass has to be on the center line. So the x coordinate of the center of mass has to be 11 centimeters, or 22 divided by 2. So that's our answer for A. We don't even have to do a calculation for A. So A, the answer is 11 centimeters for our x coordinate of the center of mass. Now for letter B, we have to find the y coordinate. We actually do have to do some math. So this brings me to our second point, which is when we have uniform rods, something like this, or a uniform plate, or a uniform sphere, or something like that, we can say that all of the mass of that object is concentrated at the center of that object. So what I mean by that is that all the mass of this, we'll call this L1 for mass 1. Let's call this one mass 2, and we'll call this one mass 3. All of the mass for mass 1 is located at this position right here. All of the mass for mass 2 is located at this position right here. And all of the mass of mass 3 is located at this position right here, at each rod's center of mass. So now we have to find the center of mass of the system. Okay, so in order to do that, we have to locate each of the center of masses, each of those center of masses, English, and find the y coordinate of each. So remember, so for part B, we want to find the y coordinate of the center of mass of the system. So that will be mass 1 times y coordinate of 1 plus mass 2 times y coordinate of 2 plus mass 3 times y coordinate of 3. And then we're dividing that by mass 1 plus mass 2 plus mass 3. So for this, I can see that I'm going below the x-axis, so that is a negative y coordinate. Now for mass 1, I can see that's in the middle of the rod. That rod, again, is 22 centimeters long, so that y1 is going to be a negative 11 centimeters. So we get y, center of mass, equals mass 1, which is 14 grams, because each of the vertical rods are 14 grams. We can just keep this in grams because the unit of grams is going to cancel. So we end up getting 14 grams for mass 1 plus the y coordinate of mass 1, which is negative 11 centimeters, plus mass 2, which is this top rod right here. But we can see that the y coordinate is going to be 0 for mass 2 because it's on the x-axis. So that whole term right there is actually going to cancel out, all right, because the y coordinate for mass 2 is 0. Plus mass 3, which is also 14 grams, times the y coordinate of mass 3, which again is a negative 11 centimeters. And then we're going to divide this whole thing by mass 1, 14 grams, plus mass 2, 42 grams, plus mass 3, 14 grams. So we end up getting 14 times negative 11, and then we're going to add the same thing, so I'll just multiply that by 2. And then we're dividing the whole thing by the quantity, 14 plus 42 plus 14, and we end up getting a negative 4.4 centimeters. And this makes sense, right? Because that means that our center of mass is closest to that top rod up there, because the y coordinate of that top rod was 0, and that top rod is the heaviest thing in this system right here. So the center of mass should be the closest, should be close to that top rod because it's so heavy. So our answer here for A was 11 centimeters, and our answer for B, the y coordinate, was a negative 4.4 centimeters.